Hello, everybody. Thank you for coming. My name is Andy Waddell, and I'm a technical program manager here in Google Cloud. And it is my great pleasure to introduce you today to a new service offering from our partner, IBM. The name of the offer is IBM Power Systems for Google Cloud, and it's a new infrastructure as a service offering that you'll be hearing about today. Before I introduce you to my IBM colleagues who are going to run most of the presentation, including showing you a real live demo, I want to emphasize a little bit about what it means to be an integrated service with Google Cloud. So the name of the offer, again, is IBM Power Systems for Google Cloud. So what does the for Google Cloud part mean? And what we hear time and time again, and what we've learned throughout doing trials of this, is that our end customers want to consume a third-party service, but very much in the same way they are used to consuming a first-party Google service, so like Google Compute Engine, Google Cloud Storage. And that can mean a lot of things. But for the initial integration effort on this offer, we focused on 4 areas. And I just want to highlight those areas, and then we're going to have lots of demo time. The first is billing. And we've integrated the billing such that you would purchase this offer from IBM through the Google Cloud Marketplace. The billing is done through Google, and it will show up on your cloud bill as a line item along with all the Google services you consume. It's all going to be offered on a monthly subscription basis. And based on, we'll get into that based on the amount of infrastructure you wish to subscribe to. The second is the user experience, and this means that when you're interacting with IBM infrastructure, it should be just like you're interacting with Google infrastructure. That's the web UI, the command line tools, the API, and I'm really excited that what you're going to see is a brand new set of capabilities that the IBM Power Systems software team has developed to make this a good match for Google Cloud. I'll leave most of that for the demo. The third area is networking. And we spent a lot of time carefully architecting the network architecture between the IBM resources and the Google Cloud resources to ensure a very low latency connection, one that is highly available and fault tolerant, and can also scale up as demand grows. And most importantly, is very secure. So we'll touch on this a little bit later, but when you connect to the infrastructure from IBM, you're never going over the internet. It's all done in private IP space that you get to define as a customer. And the last one is not as technical, but it's equally important, which is customer support. So we're expecting you'll put some very critical workloads on this infrastructure, and we want to support that. So Google has stepped up and is going to do tier 1 support for this offer. And so what that means is if you have an incident, you'll contact Google support at whatever tier you are already with Google. We'll take command of that incident, and if we need to escalate to IBM, we'll do that transparently and resolve the issue for you. And so with that introduction, I'd like to introduce a colleague at IBM, Carl Burnett. Carl's a distinguished engineer in the IBM Power Systems software group, and he's going to lead you through a small deck, and then we'll have a demo time and question and answer at the end. Thank you.
Thank you, Andy. So good afternoon, everyone. Before I get started, I want to do one more intro. Kyle Johnson is a colleague of mine from IBM, one of our senior developers, and he's going to take you through a live demonstration of what we've been working on later in the presentation. So hybrid multi-cloud is a very important part of IBM's overall strategy. And it's really about bringing our IBM solutions to the customer wherever they are on their cloud journey, whether it's on-prem or off-prem in different off-prem IT models. And there are industry studies that reveal that most enterprises will continue to run some portion of their IT and their solutions in their own data centers, but at the same time, most of those customers are on a journey to run some of their IT infrastructure off-prem in hosted environments, public cloud environments, business partner managed solution environments. And of those clients that are exploring these different options, on average, they're looking at least 4 off-prem options for their solutions. So bringing Power Systems onto Google Cloud gives our customers another great option as they go down that journey with on and off-prem IT infrastructure. The solution we're building is an infrastructure as a service solution. And it's based on our IBM Power Systems running our Power VM virtualization stack. The subscription model is actually a capacity for subscription model with a monthly price. And it's built on a concept we call a cloud instance. So think of a cloud instance as a bundle of compute, memory, storage, and network. You then take that cloud instance and we give you a user experience so that you can create and manage one or more virtual machines within that slice of infrastructure. Okay, so that's a cloud instance. You might also hear me refer to it as a t-shirt as we go through the presentation because we think of them like t-shirt sizes, small, medium, large, extra large, and so forth. Okay. Now in the solution, IBM runs the infrastructure. So we're managing the hardware, the system software stack. If you're familiar with Power Systems, you know, those different hardware elements like our HMC and so forth. So we're taking care of that, maintaining it, patching it, you know. But once the virtual machine is deployed with a running operating system, it's the subscriber's responsibility to manage and maintain the operating system and the stack up. I want to just do one quick show of hands. How many of you are familiar with Power Systems? Terminology like LPARs and HMCs. Okay, great. So I'm talking to a crowd who knows our vocabulary. Very good. Now the last part of this solution involves a low latency interconnect or network between our power infrastructure footprint and GCP. And this gives you a private low latency network between GCP resources and Power resources. So for example, if you need to run a database on Power on the back end and you want to run your app tier on GCP compute, right? They're close to each other, they're connected on a low latency network, and you can run that hybrid workload. If you need to store your data in GCP cloud storage, you've got a private, you're inside the Google network, you can use GCP cloud storage from your AIX instance, for example. Okay. While it is an IBM solution, you'll subscribe to it through GCP Marketplace. So just like you subscribe to other resources and offerings through the marketplace, there'll be a tile for Power Systems. You see an example draft of that tile here. And this is where you'll go and see the different cloud plans that you can purchase, the cloud instance plans. And here's just a simple example of what we might call a starter cloud with 16 cores, 160 gig of RAM, and 12 terabytes of storage. And then you can take that and partition that up into virtual machines. I mentioned earlier, we think of these in t-shirt sizes, so an experience you'll be able to have through the marketplace is that as your needs grow or as your journey here evolves, you can change plans. So let's say you start with a small t-shirt, and then you get to a point where you realize you need more capacity. You can upgrade to a medium t-shirt or a large t-shirt. And maybe you only need to do that for a temporary basis, and then you can go back, let's say, from a medium t-shirt to a small t-shirt. You can downgrade as well. So the GCP Marketplace allows you to do that. Okay? So what's under the hood? So we're starting with Power 9 technology. That's our latest generation of Power. And we've built an infrastructure concept we call a pod. Think of a pod as multiple racks of equipment that we've put together for you. While we're starting with our 2-socket 922 systems, our architecture is such that we can incorporate any of our Power VM-based servers into this environment. So we could put a 192 core, 64 terabyte server in this infrastructure, and it integrates into GCP the same way that 2-socket server does. Okay? It's fiber channel connected storage. We're leveraging 25 gig networking down at the servers, 100 gigabit across the racks, and then that feeds up into an interconnect tier to GCP. From a system software perspective, it's the same Power VM stack that you're probably deploying in your own data center, or if you're a partner, it's what you've been building and servicing for your clients. My key point here is this is the same type of infrastructure that you deploy and use in your own data centers. It's fully compatible. That's by design. It's the same infrastructure that we've done all our ISV certifications with and so forth. So to manage your cloud instance, we've built a new management experience completely from the ground up. And it starts with an open API compliant REST API that we've built. We've actually built it on GCP. It actually runs on Google Kubernetes engine. It's a microservices-based architecture. And that API is what sits on top of our infrastructure footprint and provides all the operations for virtual machine lifecycle management and general service management. So everything from creating a new VM or LPAR to stopping, starting, modifying it, ultimately deleting it if it comes to end of life. And we've also put in functionality around managing your boot images or your VM images, that you can bring your VM images from your own data center up into the cloud. We'll have some stock images for you. And then also managing your storage, what we call your data volumes. And Kyle's going to show you a little bit more detail on that later in the presentation. On top of that API, we've built a couple of user interface experiences for you. One is a web console experience, and you might notice it has a similar material design to GCP Compute, and that's on purpose. We want it to feel like a natural extension of GCP for you. So while it'll look and feel a lot like GCP Compute, but it'll also expose some of the unique features of our Power technology. For example, shared cores versus dedicated cores, right? So where it makes sense, we've actually made those capabilities available for you to control as you build and manage your virtual machines. We've also provided a command line interface tool as part of the user experience. And one interesting feedback that we've had, we did a POC last year with several of our clients, and we had overwhelming feedback that an API and a CLI was more important than a point-and-click GUI. So we've actually put more focus in our development efforts for the initial capability around the command line interface, because that's actually what the customers told us they wanted. And the command line interface we built is called pCloud. If you're used to using gCloud Compute, this is going to feel very similar to you. It's just, again, a natural extension, and it gives you a command line model for that virtual machine management. Now that once you've created these virtual machines, you'll need to access them. And to do that, we've built a very innovative data plane architecture in partnership with Google that gives you a mechanism so that you can access the virtual machines in your cloud instance from a GCP project. And it's a natural extension of your virtual private cloud set of networks. It's just another network that gets integrated into your VPC and provides a private IP address model to control the access to your virtual machines. And I'm actually going to bring Andy back up to take you through a little bit more detail of the set of technologies that have made this type of integration possible.
Thanks, Carl. I don't need that. So I mentioned this earlier, and I'll just give you a little bit more detail. We can follow up later. But at Google, we have a lot of services that we develop natively that follow a similar model where the service itself is exposed over a range of IP addresses that you as the customer need to specify, because you have your own IP addressing scheme. You may have on-prem IP ranges. But we're always talking about RFC 1918 private address space here. So for the first time ever, we made this technology available to a partner, and IBM in this case. And the way it works, it's based on an aggregation of several Google networking technologies that were put together in an architecture. So if you were to subscribe to this offer, let's say you were client one, you would first initiate the purchase in the marketplace, and then you would specify a private IP range that you wish to use. You would reserve that inside your Google VPC in your project, and then we would give you a peering command, which you would need to run because we can't control your project. And what that peering command does is it peers you to another VPC inside of Google, but that's owned by IBM, and that's the end of it. The rest of the plumbing network-wise is handled by IBM. They have to, obviously you saw they have real hardware sitting behind this, so they handle the hybrid network connectivity, attaching VLANs and all that, but that's all transparent. All you see is some advertised routes for the IBM LPARs, and similarly, your routes on your private VLAN are advertised back. So we think that you'll find it very, very simple to use. Most of the complexity is handled by the provider, IBM in this case. And it's going to be very similar to if you've ever used like a Google Cloud SQL. It's a very similar workflow, and there's many more Google services that are following this model. Oh, one thing I guess to point out in case it's not completely obvious, there's no connectivity into the IBM LPAR world from the internet without going through Google Cloud to begin with. So that's important for security, and it gives you all the features that the Google front end has in order to secure the workloads that you're running in IBM.
Yeah, so thanks for bringing that up, Andy. So again, a key point here is we wanted to make sure that when your VM is created, it comes out secure, right? So it's protected inside your GCP project as a private IP. And it's really up to you to decide how you're going to make it accessible, whether you want to open it up to the internet through a VPN solution or a jump server solution, or maybe behind an application server, or maybe your intention is to run a direct connect all the way to your on-prem data center and have connectivity all the way from your data center to the backend Power 8 virtual machines. So we wanted to give you the ability to fully control that, but we also wanted you to be able to leverage the rich diversity of services that GCP has and their expertise around networking capabilities. Okay. And we're gonna wrap up the presentation here pretty quickly because we really want to spend time showing you this, and we also want to leave plenty of time for your questions. But if you want to get with us for more details, please contact Ming or Sinu here on the screen. You've got see their email addresses, and we can have more of a one-on-one dialogue with you to get more into your needs and more into the details of our solution. Also, there's a questionnaire. There's a link here to this questionnaire that we put together. It's a Google form. And please, we'd like to have you come and fill out that form. Tell us a little bit about your environment, what you see as your requirements for a cloud-based power solution. And that helps us understand what we need to build, but also helps us understand how we can help you. Okay. And so with that, we're going to do a demo to give you a much closer look at what we've built. And turn it over to Kyle.
Okay, my name's Kyle Johnson, and I'm a senior engineer at IBM. And I've been working on more of the development side for this project. So today I'm going to give you kind of a walkthrough of the UI that we have created, and then the CLI. So all of this that we've created today, we did build like a full API for all this. So all of our UI and our CLI is utilizing that. So in turn, we're kind of testing as we go along our APIs with our UI and CLI. So today, I'm going to kind of skip over the kind of marketplace area. So normally in Google, you would go to the marketplace and you would subscribe, to this. And so let's just assume that we've already gone ahead and we subscribed. And so now we're going to be brought to our kind of dashboard for managing our power resources. So for the demo, I've gone ahead and I've already created 2 partitions. And so real quick, we're going to go in and look at this demo power. And here you can see the look and feel is very close to what you would see on GCP. We tried to change the colors a little bit so you wouldn't get too confused. So you might think you're actually in GCP, but here you're actually managing your power resources. So if you look, you can get your basic information, the name. Right now we have this in the data center running in US East 4. So this is not running on my laptop. This is not running somewhere in my office back, in Austin, Texas. This is actually running in our data center. So this has all been deployed. You can see here we have an active state. This is running on an IBM S922. We're using, of course, IBM's kind of shared processor feature in Power hardware. We gave it kind of half a core and then 4 gigs of memory. This one right here is actually an AIX 7.2. And then down here, you can kind of manage your SSH keys that you'd like to deploy to the VM. You can manage any type of data disk you'd like to attach. And then on this tab here, we have this kind of networking tab. And so when you sign up for this service in Google, we're actually going to go ahead and create this VPC peering network. That's kind of part of the sign-up process. And so when you come in to start creating your first VMs, you're going to have this GCP kind of network sitting there for you. And this is going to be the bridge between your GCP project and then down into your kind of power resources. You are free to also create other private networks. So you could actually have a private network just for your power hardware, maybe for some sort of like intercommunication. But this generally will be how you can kind of talk to your x86 to your PPC resources. Up top here, we have some kind of actions you can run. But here, I'll just show you that you can kind of click on the open console. And we're going to go ahead and it'll immediately pull up the AIX console to log in. So then here's AIX, and I can do an lpar stat. And you can see it has 4 gigs of memory and a 0.5 CPU entitlement. So, everything's kind of jiving here. Okay, let's go ahead and actually do what most people would do when they log in, is let's go ahead and create a new power resource. So we're going to call this Google Next 19 UI. It's going to be deployed in our US East 4 location. We're going to go ahead and use shared processors. And let's give it 1 1/4 and 6 gigs of memory. We're going to go ahead and just use our AIX 7.2 image that we have out there for us. And then we'll go ahead and just select kind of our default GCP network. So I'm going to go ahead and click Create. And you can see here, I'm kind of zoomed in, so our UI is kind of crushed. But you can see here, it just went ahead and created this Google Next UI. Some of the information here is not going to be available until it all fully gets deployed. But in a minute, we'll do like a refresh, and I can show you like the IP in its current state. So normally for me, is I use the UI to kind of test the features and see what's available to me. But when I really want to get some real work done, I usually switch over and kind of use the CLI. So let's go ahead and give you a nice, good demo of our pCloud CLI. So starting off, what? Oh, okay. Is that too small for everybody? Or needs a little bigger? Okay. Okay, so as you can see, we kind of called our command pCloud to be really close to gcloud. So I guess, the best form of flattery is kind of imitation. So most of our commands are going to feel very, very similar to what you would normally run on gcloud. So in this kind of root context here, the main 2 available commands that are important to you are the compute command, which is very similar to gcloud compute, and then config, where you would kind of set your project. So if I go ahead and I click pCloud compute help, you can see the kind of main sections that we've created here for you to kind of manage your power hardware. The first one is clouds, and so this is where you would switch between what we call a cloud instance for power. Like earlier, we talked about t-shirts. So this right here would be the different types of cloud. Like you could buy different t-shirts and bundles, and this is where you would manage those clouds. Images is all of our OS images. So this is where you could have your AIX 7.2, 7.1, maybe any Linux images you might have. Instances are your actual Power VM instances. Networks, that's where I talked about earlier. This is where you could create your private networks and also have manage your default GCP network. SSH keys are where you can add new SSH keys to be deployed when you actually provision your instance. And then finally, volumes are all your data volumes. So let's go ahead and list our clouds. And you can see here I have one t-shirt that I purchased, and I called it Cloud 9. So we can go ahead and do a describe on that cloud. And you can see that this cloud, I created it earlier, so it's kind of small. It has 20 processors and 60 gigs of memory. So now I can go back and type in my config set cloud. And this is kind of going to set up my P cloud to just be managing that one cloud resource. OK, so now we can go into compute. And let's look at some instances that we have. So you can see here, I do have the two that I showed you earlier. And then even now, our new UI one has shown up. So we can also dive in a little deeper. And we can go look at this demo power. And you can see here we get a lot more detailed information. We have 0.5 processors again, 4 gigs of memory, showing the IBM system type, your IP address, your MAC address or network. And we give you some IDs, so different volumes that might be attached, or the OS image that's currently installed. Look at SSH keys. I do have one here that I've created before. We can also dive in a little deeper to the SSH key. And you can see here that I also do support multiple formats. So like gcloud, you can specify JSON, CSV, table, a YAML, and it's going to return in that format. If you're familiar with gcloud, you'll notice that, that every command kind of has a default formatting, and we kind of follow that same suit. So most lists are going to be in a table format, and then most describes are going to come back in YAML. But you're always allowed to override that with the format command. Let's moving on. We can look at images. So images here, we have an AIX 7.2. So that's kind of been installed into your cloud instance storage. We do have a way here that IBM is going to keep a collection, like a catalog of images for you to use that are kind of stock images. So if you do the available command, you'll be able to list all the stock images available for you to copy into your cloud. Next, we'll look at networks. So you can see here, there's that default GCP network that I spoke of earlier. Let's go ahead and do a describe on that network. So you can see here, I can get the information about my CIDR, my IP ranges that will be assigned to my partitions when they're created. I have my gateway, and you can also assign any type of DNS that you would like for your instances. So you might actually have a cloud DNS that's running inside GCP that you can kind of do the routing for, or you could even maybe deploy your own bind server down in your Power Colo or your cloud instance. Okay, we'll look at volumes. So right now I have a test volume that was sitting out there. Let's go ahead and try to create a volume. So you can see here we have many options, but the two that we really care about today are going to be size and the type of volume you want to create. So we are going to support right out of the box. We're going to have standard disk and flash disk. So you'll be able to create either one when creating your data volumes. So you can see here, we can type in GN19 disk. We'll give it a size of 20, and we'll go ahead and use a standard disk for now. So now our volume's been created. So let's go ahead and actually create an instance on the command line. So here's the help for that. The main thing to take away, it's very similar from earlier on the UI. We're going to supply an image. We're going to supply some memory, networks, the processing you want to use, the processor type, which could be shared or dedicated. So today we're going to actually use shared. And then we can also supply how much memory we want to use. And we're going to go ahead and we're going to attach that volume that we just created earlier as a data volume to this partition. So I go in and hit enter. So you can see here, our instance was created. And so I think a message to take away here is, when we create these instances, it's being deployed into a cloud, so not everything's instantaneous. So right now, a lot of stuff's going to be, getting provisioned in the backend. But we can go ahead and do a list. And you can see here, we now have a Google 19 CLI that we've just created. And let's dive in a little deeper. We can do a describe. And you can see right now, we specified 0.5 processing. We had 4 gigs of memory. And the big thing important here now to say is the status is in the build status. So right now, we're still provisioning this instance. So the build status will change to OK when it's ready to start doing some more operations. But some information like the networking, that's going to be show up later once it's actually been resolved. Okay. But we can go ahead and pull up a console. So just like the UI, you can run the command for console on this instance. And what it's going to do is it's going to return you a one-time URL. And so when you click on that link, you're going to be brought to the prompt here as it's installing AIX. So you can see here from the CLI, we've gone ahead and we've created an instance, and then now we're actually logging in to the console. So we'll give it a few seconds, and then let's see if we can get the prompt to come up. Okay. I guess we want me to do DLPAR now? Yeah. Okay. Okay. Actually, now I think I'll switch, and let's do some more. Oh, here we go. Well, I'll let that run in the background. Okay. Let's go ahead and do something more interesting that's kind of more available on Power. So as you may know, we can actually change resources while the operating system is running. So on Power, we're going to do what we call usually internally we call a DLPAR operation, or our dynamic kind of partitioning. So let's go ahead and do a list. Let's use the demo Power one. So we'll do a describe on demo Power. And you can see here it has 0.5 processors and 4 gigs of memory. So let's go ahead and pull up a console. We're going to log in. I'll do an lpar stat here to show you that we have 4 gigs of memory. Sorry, it's hard to see the prompt here. 4 gigs of memory and 0.5 processors. I'm going to go ahead and do a VM stat 1. So this is just going to be like a simulate, just like a job running on the system, so we know that it was actually live. Let's go back to my prompt here. And let's go ahead and perform an update while it's running. So let's look at the update command, for instance. Right here, I think we're really important. We want to just change the processors and memory. You can also change the name, but that really wouldn't be a DLPAR. So let's go ahead and do processors to 0.75, and we'll give it 6 gigs of memory instead. So we're going to go up 0.25 on the processor and 2 gigs on the memory. Let's go ahead and enter. So that's been updated, and now we can go back to our prompt here, and while this is being initiated, you're probably going to see a little message from AIX telling you that the processor memory has been changed. Right there, it kind of showed up really quick, but it's giving you it's telling you that we have 6 gigs of memory and 0.75 processors. So let me go ahead and stop this prompt. I can do an lpar stat here, and you can see that while it was running, we've just increased to 6 gigs of memory and 0.75 processors. And we can go back to the, sorry, I keep clicking the wrong thing, to the command line, and we can do a describe. And you will see that it's also been updated on the command line. So now we're matching what it shows, 0.75 and 6 gigs of memory. I think also I can show you, so I'm actually running this pCloud inside of GCP. So I've created an Ubuntu instance in my GCP project. So I could technically go ahead and I can actually ping this, this network all the way from GCP down into Power. So this is the full link running. So I'm actually running pCloud on just some random VM that I have in GCP. But I can also talk to the network down in the Power colo. So that's the part they talked about earlier, with the VPC peering. So it's pretty interesting. All of it works. We have a fully fledged CLI and UI. So, oh yeah. So the latency, you can see it's sub 1 second millisecond. So it's very, very fast. Oh yeah. So real quick, let's see. just go back. I wanted to show you, we created this UI earlier. I don't want you to call me a liar, so I want to show you that our AIX actually did boot up here. So there you go.